Hey there, chemistry fans. Today I'm coming to talk to you about a very important topic. It's known as hydrogen bonding. Hydrogen bonding is really a lot of times the answer when you're talking about intermolecular forces. It's kind of one of the most important intermolecular forces because it's what gives water a lot of its unique properties. And so, hydrogen bonding, I've found, has come up sort of an inordinate amount of times when they're asking questions for Unit 3 or even on the AP exam. You're going to see a lot of hydrogen bonding. So, a hydrogen bond, it's an intermolecular force, okay? So it is a force between molecules. And it's formed when hydrogen is bonded to one of three elements: nitrogen, oxygen, or fluorine. And I always remember that because I say the word "NOF." Okay, and there used to be a cartoon character that I watched with my little sister when she was a kid, and it was Pinky in the Brain, and Pinky was always going "NOF" like that, and so that's how I remember it. NOF, NOF. Those are the three elements that activate hydrogen bonding. Okay, so when you draw a water molecule, it's pretty simple here, like that. These are your intramolecular forces, the forces within the molecule, okay? And those are two covalent bonds between hydrogen and oxygen. Now, if we apply Coulomb's law, what we're going to realize is that this oxygen has 8 protons, and it's pulling electrons with 8 protons, and poor little hydrogen only has 1. So the electrons are going to be pulled much closer to oxygen because oxygen has more pull for the electrons. Now, what that does is that creates a polar molecule. And so those are sigmas. And so around the oxygen, you get sort of a negative pole, and around the hydrogens, you get a positive pole. And so, because it is a polar molecule, it experiences these regions of charge, and it interacts really well with things like ionic compounds. That's why salt so readily dissolves in water. And in other polar compounds. And it's also why oil and water don't mix, because oil is a nonpolar compound because it's made up essentially mostly of carbon, and hydrogen is the backbone of all oil and fats. And that's why oil will sit on top of water, because oil's nonpolar, because the bond polarity difference is not that great, and water is polar. And the rule to remember when you're dissolving things is like dissolves like. So polar things will dissolve other polar things and ionics, and nonpolar, just other nonpolars. So when you get to the idea here of maybe another molecule of water, okay, so when you put another one in there, that's a negative. So what's going to happen here is this negative region here is going to be kind of attracted to this positive region here. Now, it's not the strength of a covalent bond, which is an intra, within, I-N-T-R-A, within, but it's still going to have a connection, okay? And so you're still going to have that connection there. Now, then if you put another one in there, you can see that you're going to get kind of this web forming, okay? And that web that's formed by that water allows it to have a very low vapor pressure. Water likes to stay in liquid form. It has a tremendously high boiling point for its mass, and we owe that to its hydrogen bonding. And also the surface tension of water, the fact that water beads up, or if you've jumped into a pool and done a belly smacker and that didn't feel all that great, that's because water is forming this sort of web of secondary connections, and it allows water to kind of have a skin on it, which is kind of gross but also kind of cool. Okay? And so if you would have another type of molecule in there, like a ammonia is always a fun one to do. So here you see the ammonia, and the nitrogen's going to be negative and the hydrogen's going to be positive. And so you're going to have positive here and negative here. And that positive region on the hydrogens will just be attracted right here to those oxygens. And that's how hydrogen bonding works. Okay? Now, I know the next question that one of you bright scholars is going to ask me is, what's so special about nitrogen, oxygen, and fluorine? They are very small. They don't have a lot of shielding. And they, it's kind of a perfect mix of them being small enough, but also large enough to bully hydrogen. And so the other elements on the periodic table that would kind of be eligible for this are just too big, and there's this shielding that's there that doesn't make it something that's possible. So really, for hydrogen bonding, and it's a very important concept, you just have to remember that it's hydrogen bonded to nitrogen, oxygen, or fluorine.